In the last part of this notes, we're going to talk about the second fundamental theorem of calculus. So let's think about what the derivative of x squared is. Pretty simple, right? 2x. Now if I asked you to work backwards, what's the integral of 2x dx? That's finding the antiderivative. So adding 1 to the power, it's going to bring you back to x squared. So now we're kind of putting it together. If I asked you to find the derivative of the integral 2x dx. So first finding the integral will bring us to x squared, and then find the derivative of that will bring us back to 2x. Notice it brings us back to the exact same thing. Derivatives of integrals bring it back to the same function. Now thinking about that, let's move back to the notes. Here we can see the definite integral of a number, where a and b will both be numbers, right? And then we get an actual answer. Now we're looking at definite integrals of a function. A will be a number, and then we have x, which will be a variable. So what we want to do is evaluate the function from 0 to x of cosine t dt. What we're going to do is find the antiderivative of cosine, which will be sine t, and evaluate from x to 0. So plugging in x, we get sine x minus plug in 0, sine of 0. So then we have sine of x, and the sine of 0 is 0, so our answer is just sine x. Let's look at this here, finding the derivative of the function. So now the derivative of sine will bring us back to cosine. So the derivative of the integral brings us back to the original function, except notice the variable has now changed to an x. So the derivative of the function is the original integral, but only the variable will be changing. So we're finding the derivative of an integral where only the variable is going to change. This is the second fundamental theorem of calculus, otherwise known as the desert island formula. Desert island. So notice we're finding the derivative of a function brings us back to that derivative integral of a function brings us back to the original function. Notice the t changed to our upper bound variable of x. So simple instructions, replace t with the upper bound, and don't forget to replace dt with the derivative of the upper bound if it's more than just x. So in example 9, find the derivative integral brings us back to the original function, except replace t with x, and replace dt with the derivative of x, which is 1, and so multiplied by 1 just gives us this original. Let's try 10. Derivative of an integral of its function is going to bring us back to the same function, except change t to the upper bound, x cubed, and then multiply by dt, which is the derivative of the upper bound, 3x squared. And so I'm just going to rewrite it with 3x squared in front. And this is the second fundamental theorem of calculus.